I'm Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today, I want to discuss about the network programming and management subject, in which the topic is Ipv4 and Ipv6 interoperability. Ipv4 means Internet Protocol version 4 and Ipv6 means Internet Protocol version 6. Both are interoperable. Both are interoperable. That means the meaning of the interoperability here. Ipv4 is working one network and Ipv6 is working another network. Here we can sending the information. We are sending the data from Ipv4 network to the Ipv6 network. That is a interoperability. The overview of the Ipv4 and Ipv6. Ipv4. Ipv4, it is a Internet Protocol version 4. That means in this Ipv4 version 4, totally we can maintain 2 to the power of 32 protocols, which contain this version, which contains the 2 to the power of 32 protocols. That means which uses the 32-bit address space, which allowing approximately 4.9 billion unique addresses. If you see the address format, dotted decimal notation 192.168.0.1. So this is an example of the Ipv4 address. If you take Ipv6 is a Internet Protocol version 6. In this Internet Protocol version 6, total we are utilizing 2 to the power of 128 IP addresses. In Ipv4, we are using 2 to the power of 32 IP addresses, and in Ipv6, we are using 2 to the power of 128 IP addresses. Ipv6, it is a enhancement of Ipv4. Ipv6, it is a enhancement of Ipv4. Ipv4, it is a existed. Ipv6, it is a enhancement. Here in Ipv6, we use 128 bits address spaces. 128 bit address spaces, which are providing a large number of addresses, around 3.4 into 10 to the power of 38. Why? Because here we are using 2 to the power of 128 IP addresses. The address format of Ipv6 is, this is our address format of Ipv6. Here example 2001 colon 0DB8 colon 85A3 colon 0000088A2E 0370 colon 7334. So it is a hexadecimal notation. Now Ipv6 address format can be represented in a hexadecimal notations. So this is a overview about the Ipv4 and Ipv6. If you take Ipv4, the space is very long comparing than the Ipv6. The more which has the address space is address space is more than Ipv6. Next, mechanisms for interoperability. interoperability means communicating from one network to another network by using the IPv4 and IPv6. One network we are using IPv4 protocol, another network we are using the IPv6 protocol. So this is a interoperability. The mechanisms are dual stack implementation. What is the meaning of the dual stack implementation? Dual stack implementation means that means in particular source side or destination side, both the protocol versions can be used in a dual stack. Suppose if you take it is a host at a source side and router, we are using router. So it is a host, that means at a destination side. It is at source side. So it is a host at a destination side. Here is interoperability. So the meaning of the interoperability, that means the device and applications operate with both IPv4 and IPv6. So this device, which is dual stack device, it is a dual stack device. When you can say it is a dual stack device, that means whenever this other device using both IPv4 and IPv6 protocol versions, we can say it is a dual stack host. Here we are communicating via the router. So the router communicating via the router with the destination device. The destination device also, it is also dual stack. That means this device also, which is having the both IPv4 and IPv6 protocols. That's why network are the programming libraries which are providing the support for both the address and the families. So this side network and destination other side other networks now, which is providing the support of the IPv4 and IPv6 address. A server listening on the both IPv4 and IPv6 addresses. And tunneling, it is a mechanism for interoperability. In tunneling, what we are doing, we are inserting the packet, encapsulating the IPv6 packets within the IPv4 packet to traversing IPv4 network and vice versa. That means now tunneling in a communicating channel or in communicating media, the packets can be transmitted from one device to another the device. While transmitting the packet from one device to another device, now we can using the tunneling concepts. That means one packet is inserted within the another the packet. So that is a tunneling concept. That means encapsulating IPv6 packets. Here is wrapping the data into the single unit. Whatever the data we are transmitting with the help of this IPv6 version, that the packet data can be encapsulated into single unit within the IPv4 packets. That means if you take, so it is a one packet, that is IPv4 packet. So it's a header and it one is a payload. That means now we are inserting within this IPv4 one more packet we are inserting. It is a IPv6. That means now it is a tunneling process. by inserting one packet into the another packet, we can transferring the data, we can establishing the communication from one device to another device. That is commonly used when the networks are not fully upgraded to IPv6. For example, 6 to 4 tunnels, Gerard. So these are the examples for the tunneling. Translation. Next, the mechanism is a translation. Translation. That means here translating the IPv6 packets to IPv4 packets. So one packet into the translating from one packet to another the packet format. Here, which enabling the communication between IPv4 and IPv6 only host. For example, DNS64 system mechanism. So this is a translating. In this DNS64 system mechanism, we can transfer the IPv4 packet into IPv6 IPv6 packet. That is a translation. One format to the other format. Now we can translate. Network programming and considerations. Network programming considerations are socket API changes. That means which is using the address family internet for the IPv4 protocol version and address INET 6 other family for IPv6 protocol. So this is the socket API changes depends upon the address the family. Now we can changes the socket API. Stuck socket address in for IPv4 and stuck socket address in 6 for IPv6. That is IPv6 that means no, which is the IPv6 means, so it is a version of 6 and IPv4 means which is a version 4 socket addressing. Now these two are the versions of the protocols can be utilized as a network programming consideration. Next up, handling dual stack sockets. Handling dual stack sockets means here now both the protocols can be used. IPv4 and IPv6 both the protocols can be used. Here is how to handling that both the dual stack the protocols means now we are creating the sockets first. That both the side, that means at a server side, at a client side, now we can creating the sockets that can handle both the IPv4 and IPv6 traffic at same network. Example, using the address family INET 6 with IPv6, v6 only socket option set to 0 to allow the dual socket operations. Next, address resolutions. By using the address resolution also now we can handle the dual stack sockets at the client side or at the server side. Using functions like get address information which can handle both IPv6 and IPv4 addresses that can be returns the result that can be used for creating the sockets at both server side and client side. This can help within in writing the protocol code. For protocol, whatever the protocols now we are utilizing at server side and the client side. Now with this the help of this one, now we can write the code for the protocol implementation. Real time the applications of IPv4 and IPv6 interoperability. The real time applications generally are the systems or softwares that process the data and provide the immediate feedback or the result. Here is these applications that can be designed to operate within a set the time constraints. That means it can be designed based on the time considerations. Within this, why we are considering the time means here, within this the time we have to transfer the data packets from one device to the other device within a time factor. That's why the time factor will be considered in a communicating from one device to another device. So that means here in milliseconds or seconds. So to ensure so that the timely and efficiently which the performance of particular the device. Here some of the examples and the categories of the real-time the applications are telecommunication. The communication is one of the real-time application. Now in this the telecommunication you can utilize the both IPv4 and IPv6 protocols. That means the telecommunication voice over internet protocol we can utilize for providing the services like Skype service. Now we can provide Zoom meetings, any other conference that can be conducted, which requires the real-time audio and video other communication. So in a real-time audio and video other communication, now we can utilize these IPv4 and IPv6 the protocol. By utilizing these the protocol, now these the conversations can be effectively done the conversations. Here is online gaming. Online gaming also, now we can utilize the IPv4 and IPv6 multiple players. When we can use this IPv4 and IPv6 in online gaming means here, whenever the multiple players are playing in online gaming, so in this situation, now we can use these IPv4 and IPv6 protocols. That means multiplayer online game where immediate response is very critical for the game player. And the financial systems. Financial system, that means high frequency trading systems. The trading, stock markets. So these are all in this high the frequency the trading and stock market the system, and the high the frequency the banking also. So we can utilize the financial systems. That systems know that execute trades in a milliseconds that can be based on a market other conditions. Online banking. Online banking means here real-time other transaction processing for fund transfer or account updates. That means here any online banking or any online transactions. Now we can utilize these IPv6 that means version 6, the enhanced version 6 the protocol for effective transmissions. Next, healthcare. Healthcare means here for monitoring the patient regular basis is the health the care. Regarding the health care, now we can utilize these IPv4 and IPv6 by using these version the protocols. Now we can monitor the healthcare condition of the patients. So it is which shows the signs of the patient condition with immediate alerts for the anomalies. Suppose if is there any anomalies, now immediately which give the alerts. Now, so telemedicines. Next real-time application is a telemedicines. That means real-time the consultations and diagnosis through the video or the conferencing. So these are the healthcare. Industrial automation. Industrial automation, that is a robotics. Robots which is performing the task with a precise and within the tight time frames. Process control systems. Process control system, here real time or the monitoring and the controlling of the manufacturing of the processes. So it is a industrial automations. Next application is a transportation. So in transportation also, air traffic control system, now we can utilize these IPv4 and IPv6 interoperability mechanism. So this air traffic control system, what it do, that is managing the aircraft movement in a real time. By using these the protocols now, we can manage the aircraft movement in a real time, which is these aircraft, with the help of these interoperability, the communication now which ensures that safety traveling and fleet management. Fleet management, it is a real-time tracking and management of the vehicles. By using this fleet the management now, the tracking the communicating messages or from whatever the devices are communicated, that the informations can be tracked by using the fleet the management the technique. Emergency services. Emergency services are 911 dispatch system. So it is a real-time communication and dispatching for the emergency responders. Disaster management system. Disaster management system, that means if any issues are arise in a real time, so these are the disaster management system can be implement and resolving those the issues in a real time. For example, in a railway system, what will happen means if any two trains are dashed, if any issue is arise in the railway system, now immediately with help of this disaster management system, that issue can be recovered, overcome that other issues. Disaster management system management with help of this one, now the issues in a railway system that can be overcome. Real-time data collections and response the coordination during the disasters. Here is smart grids. Smart grids are energy distribution, real-time monitoring and management of the electricity distribution to optimizes the uses and preventing the outages. That means in a electricity department, we can monitoring the energy distribution, how much energy is distributing to domestic or commercial. So now we can monitor, we can identify. So that is a smart grids. With the help of this the smart grids now we can identify, that is a real-time monitoring can be performed and management of the electricity distribution to the optimized usage and preventing the outages. Internet of Things, IoT. Here the smart home devices like real-time or the control of the home automation system such as the thermostat and security the cameras. Here is a real-time health and fitness the tracking devices. That means where's the variables that real-time the healthcare and fitness the tracking devices. Now in this IoT Internet of Things can be utilized. Here it is a IoT and Internet of Things. And multimedia. Multimedia, that is a streaming service in a real time streaming of audios and videos. The content with the minimal buffering. For content buffering purpose now we can use the multimedia, that is the streaming of the services for audios and videos. And interactive the applications. Interactive, the meaning of the interactive of the applications are the real-time interaction in applications like the augmented reality and virtual reality. So it is a interactive the applications. Autonomous systems. Autonomous systems means so any self-driving cars, AI based artificial intelligence based self-driving cars or in a metro system. So we can use the autonomous, we can use the IPv4 and IPv6 interoperability. So that is a autonomous systems. So here when this self-driving car in a real time the processing, the sensor devices. Now we are using the sensor devices, and with the help of these the sensor and the devices, now these self-driving cars, the driving car, which is identify the surrounding other things, surrounding things to the car, whatever the car, the driving car. Now we are utilizing the surrounding to the vehicle, now which can be identified with help of these sensor devices or with help of the sensing data. So it is a self-driving cars. Self-driving cars. That means which navigate and make the driving other decisions. With help of the sensor devices, now the driving decisions automatically the car will take the driving other decisions. With help of this, with the integrated along with help of the artificial intelligence based the technique, and the drones real time the control the navigation for the various the applications from delivery to surveillance. Here it is a drones, and the primary goal of the real time system. So to ensure that the critical tasks are completed within the deadline constraints to maintaining the system stability and the performance. Here is the main the differences between the Ipv4 and Ipv6. While interoperability we are performing from one network devices to another other network devices, we can describe like this. There is a address length. Address, in terms of the address length, the differentiation between the Ipv4 and Ipv6. Ipv4 is a 32-bit address, and Ipv6 is a 128-bit address. So that's why here now in Ipv4 we are utilizing the 2 to the power of 32 IP addresses. In Ipv6 now we are utilizing the 2 to the power of 128 addresses, IP addresses. Fields here is the Ipv4 is a numeric address that consisting of the 4 fields which are separated by the dot, and Ipv6 is a alphanumeric in hexadecimal format. Now we can represent the address in a hexadecimal format. That is a alphanumeric address that consisting of the 8 fields. Ipv4 consisting of 4 fields, Ipv6 consisting of the 8 fields, which are separated by the colon. Here Ipv4, each and every field separated with a dot. Here is each and every field, now it is separated with a dot, and here each and every field separated with a colon. Separated with a colon. So this is a main difference in a presentation. Classes. Ipv4 has a 5 different classes of IP address. Internet as a protocol address that includes the class A, class B, class C, class D up to class E. Ipv6 doesn't contain the classes of the IP addresses. Here the number of IP addresses. Ipv4 has a limited number of IP addresses. To take the Ipv6, which has a large number of the IP addresses. Here limited number means 2 to the power of only 32 address, which is having. So here large number of the IP address means 2 to the power of 128, but the space is more efficient and more sufficient in a Ipv4. Space and the complexity very complicated in a Ipv4. Why? Because here, because the number of addresses, IP addresses are more in Ipv6 comparing with the Ipv4. So which support VLSM, virtual length subnet mask. Here is VLSM means that IPv4 which converts the IP addresses into a subnet of the different sizes of the in a network. It doesn't support the VLSM. IPv6 now, if you take the IPv6 which is won't support the virtual length subnet mask. Address configurations. Address configurations means here it supports manual and DHCP configurations. It supports the manual and DHCP and auto configurations renumbering. Address space means now it is generate the 4 billions of the unique address. IPv4 generating 4 billions of unique IP addresses. With help of the IPv4 that can be done. And here by using the IPv6 now, it is generate the 340 and here decillion the unique addresses now which is generates. Here end to end the connection integrity. In terms of end to end connection integrity in IPv4, end to end the connection integrity is unachievable. In IPv6, the case of the IPv6 now end to end the connection integrity is achievable. Here security features. IPv4 security which is depends on the applications. This IP address which is not developed in keeping the security features in mind. So in IPv6, IP security is developed for security purposes. Address representation. IPv4, the IP address is represented in a decimal form. So in terms of IPv6, the IPv6, the representation of the IP address, now we can represent in the form of the hexadecimal. Hexadecimal here, that means IPv6 with total 8 fields. So separated, each and every field is separated with the colon. Fragmentation. In terms of fragmentation, it is done sender and forwarding the router in a IPv4. Here is in IPv6, fragmentation can be done only the sender side only. We can't do the fragmentation from the receiver side in a IPv6. Packet flow identification. Packet flow identification, that means the packet which doesn't provide any other mechanisms for packet flow identification. Packet flow identification now, it uses the flow label field in the header for the packet flow identification. Checksum field. The checksum field is available in IPv4. The checksum field is not available in IPv6. The transmission scheme. IPv4 is a broadcasting. On the other hand, IPv6 is a multicasting. So which provide the efficient network operation. With help of this IPv6 now, from sender to we can send to the multiple devices. With help of the IPv6 address, we can send to the multiple devices. That is a multicasting can be performed. And we can send to the group of workstations also. The information can be sent to the group of workstation with help of IPv6. The transmission scheme, in the terms of the transmission scheme, if you take IPv4 is a broadcasting. In terms of this IPv6 now, if you take in a IPv6, so IPv6 it is a multicasting supported protocol which provide the efficient network operations to the multiple other devices or multiple users. So that's why if you want to provide the service to the multiple users or bulk amount of the other users the data here, now we can utilize the IPv6 the protocol. With help of this IPv6 the protocols now, we can transfer the messages effectively to multiple devices. Encryption and authentication. So it doesn't provide the encryption and authentication, but IPv6 now, which provide the encryption and authentication. Here is it consisting of octets. That means here 4 octets. IPv4 which is having the 4 octets, and in IPv6 which consisting of the 8 other fields. That means on each field which is contains the 2 octets, therefore the total number of the octets in IPv6 is 16. Here is the textbooks are these are all the textbooks. There is HTML, Unix network programming, and Subramaniam network management, the principles and practices. References are internet networking with TCP/IP, SNMP, SNMPv2, SNMPv3, RMON. So edition 2 or edition 3rd edition 1999. Bilski. These are all the reference books and web references. So these are all the web references. This is about the IPv4 and IPv6 interoperability. That means the meaning of the interoperability means now we are sending the information from IPv4 device to IPv6 device. It is a meaning of the interoperability.
Like, share and subscribe. Hit the bell icon for more updates.